Linear inequalities. So these are inequalities, not equations. I'm going to start out with an equation though, just to show you how an equation is graphed, something you already know. So we start with the y-intercept of 2, 1, 2. We go up 1, 2, 3 over 1. So we start here, up 3 over 1. We connect them. And this line represents all the solutions to this equation. And we know this already. Inequalities are when instead of an equal sign you have a greater than or less than. So let's say, for example, greater than or equal to. That's an inequality. The graph is still very similar. It's still a line like this because we still have the same equation here. But we're not just saying not just the values that are on this line, but values that are greater than that as well. So in this case, I think of this like a ladder leaning against a wall, and greater would be above the ladder, anything in this region here. So we're actually going to do some what we call shading. I'll do it with a pencil here. Let's see how that looks. So anything in this region up here, as well as the numbers that are on the line, is a solution to this inequality. So we'll do some shading. Let me give you an example. Let's say, like, for example, negative 1, 2, 3, 4. Let's say negative 4, positive 2. I'll just put a dot here. Negative 4, positive 2. Negative 4, positive 2. So that's a solution to this, and we can check that by plugging in x is negative 4. So we have 3. I'll do this with a marker so you can see it better. 3 times negative 4 plus 2. That's this right here. And then this 2 is my y value. So I'm plugging in negative 4 for this x and 2 for this y. And I'm checking to make sure that this is true. 3 times negative 4 is negative 12 plus 2. Negative 12 plus 2 is negative 10. And 2 is greater than or equal to negative 10, and that's true. So this is a solution. This point right here, which is in this shaded region, is a solution to this inequality. So not only are the solutions that are on the line, but all of these points, these millions and millions of solutions, satisfy this inequality. So it's not just what's on the line, it's what's above the line as well. Anything over here is not a solution. So for example, if I plugged in 2, 1. If I tried plugging in 2, 1 in here, I'd get 3 times 2 is 6 plus 2 is 8. And then it would say 1 is greater than 8, and that's not true. 1 is not greater than 8. So this is not a solution. So any point over here is not a solution. So for inequalities, we graph them exactly like a linear function, and then we shade above or below the line. It has nothing to do with left or right, because let me give you another example here. If I used the same exact equation, but let's say I had done a negative slope. Let me see if I can do it over here. So I'll do the same function. Y is greater than or equal to negative 3x plus 2. So I would have started at 2 and going down 3 over 1. So my graph would look like this. And if you were saying y is greater than this function, I would say, again, this is like a ladder leaning against a wall. This would be greater. So this time I would shade this side. And anything over here is a solution to this inequality. Any point here is a solution. And you can test those points. These dots are called test points. So you could plug in, let's say 3, 1, and you would plug it in and you would see that 1 is greater than, that would be negative 9 plus 2 is negative 7. 1 is greater than negative 7, and it works. So this point works. Okay, so it's the same thing as graphing linear functions, only they're called linear inequalities, and you're shading one side or the other. You could also have a horizontal. You could have something like, let's say y equals 3. Let's say y is greater than or equal to 3. The graph of that looks like a straight line, right? Y equals 1, 2, 3. This is my y. So the graph looks like this. And it's saying that y is greater than or equal to 3, so it's everything above this to infinity, right? Anything above that will give you a y is greater than 3. And the reason the graph for y equals 3 looks like that is if you plugged in this point, this would be 2, 3. 2, 3. This one would be 4, 3. And you notice that y is always 3. Come out here, you'd have 10, 3. And the y is 3. So when we say y equals 3, we mean no matter what the x is. Okay, and then y being greater than 3 would be, of course, above the line, above 3. So this is a video on linear inequalities, not equations, but linear inequalities. And it has to do with shading.